Hi, and welcome to this series of videos where we're going to be looking at survival analysis with SPSS statistics. Now, survival analysis refers to a family of statistical techniques where the outcome variable of interest, the dependent or the target variable if you like, is the time until an event occurs. It is commonly employed where researchers are particularly interested in modelling the effects of things like different treatments or drugs or conditions upon patient survival time, hence the term survival analysis. And as such, survival analysis is regarded as a key procedure, a key technique used in analysing the efficacy of pharmaceuticals, for example, in studies of disease prognosis. Now, that being said, survival analysis can actually be applied in many other realms. In the business realm, for example, where over time specific events inevitably tend to appear in a population, survival analysis can be a very good fit. So these sorts of events include things like insurance claims made by policyholders. It tends to happen inevitably that a policyholder will make some sort of claim on their insurance policy over a certain period of time. Or the cancellation of subscriptions by customers or subscribers, let's say, of an online streaming service, or component part failure perhaps in a machine or an asset. At what point does that machine need to be inspected or have a part replaced on it? Or even things like employee tenure. How long will somebody actually remain an employee before they quit and go and work elsewhere? The kind of data that works with survival analysis is usually called time to event data. And these are data sets that are comprised of two key variables. The first variable is a categorical variable which simply records the outcome of the event in question. So it indicates whether or not the event has occurred yet, whether or not the patient is still alive, or whether or not they've died, or whether or not they're still a customer or they've cancelled their subscription. And the second element is the time element. That shows how much elapsed time has occurred before the event in question, whether that event has occurred or did not occur. So how long they'd been a customer, for example, before they'd cancelled their subscription, or how much time had gone by in the patient treatment window before the event occurred or did not occur. So the analysis can involve a single group, or it can in fact investigate survival time as a function of a third variable, whether that variable be categorical or interval. In fact, it can be a group of variables. In other words, we can try to predict survival time using other variables such as people's ages, or whether or not they're male or female, or how much money they've spent, or on what particular treatment regime they're on. And survival data therefore often contains what are called censored values. And these are observations for which the final outcome is not known, yet for which some information is available. So we don't know if the outcome has occurred yet, so whether or not they're still a customer or whether or not they're still alive. But we know some other information about them. We know what type of treatment they received. We know whether or not they're male or female, or what age group they belong to. But censored data and censored values is a special element and a special concept in survival analysis, and it merits us looking at it in a little bit more detail before moving on. The nature of time to event data is that it often contains censored values. It's an unavoidable issue that data points are often censored, and this refers to unknown circumstances where for example, we don't know how long the patient survived or how much time elapsed before the event occurred. It is an added complication of the analysis, but it's one that's incorporated into the various calculations that estimate survival time. So almost the survival analysis kind of expects to have censored values within it. Censored data is a particular issue in research studies, however, where it may not be possible to know when a given condition, for example, began. So there's different ways in which censored data can manifest itself. Let's have a look at a little graphic here. We have, let's say we're conducting a study and we're looking at a particular illness and whether or not a patient succumbs to that illness over a period of time. We have a study window. The study window might be 6 months in time, or it might be 2 years. It's quite common for them to have 5 years to conduct a study. And from that you recruit a number of subjects or patients, and you want to study how long they survive in a particular study window, whether or not an event actually occurs. So the first sort of example you have is an example where the event occurs, which we'll denote with a little X here, and it happened within the study window. We know how long the patient was receiving treatment, or we know how long they had this condition. It's not censored. the outcome is known. So this is kind of a known outcome. The second example here is where the patient actually drops out of the study. So the subject says, I'm not going to take part in it anymore. I'm not that interested in it. They stop turning up or for the interviews, or they stop filling out information. And that's a common problem in any sort of study. It's also a problem in medical studies as well. So that a censored value is often denoted with a little cross, and this means that they've dropped out. We don't know if the event ever occurred, or if it did occur, when it occurred. This is known as right censored data because it's happening on the right hand side of the scale, so it's not happening on the left hand side. Another way in which right censored data can occur is simply that the patient survives during the entire study. That doesn't mean that they survive forever, but we don't know when the event actually occurred. And of course, if we're dealing with mortality, everybody dies eventually. You simply may not know when that person dies if they don't die within the study window. So again, that's another form of right censored data. Then the other example is left censored data. Is that you want to know how long, let's say, a person has had a given condition before an event occurred. But if you don't know when that condition actually started, which is going to be common with a lot of medical conditions, where doctors and physicians are simply trying to estimate when it first occurred, it is effectively left censored. You don't know how long they've actually had that condition. So that's left censored, where the unknown element is on the left hand side of the study window. And then the fifth example is what's called interval censored, where we don't know exactly when the event occurred because perhaps it requires us to actually test the patient, or test them every 6 weeks or something like that, and something is detected or noticed within that 6-week period, but we don't know exactly when it occurred, whether it occurred 5 weeks earlier, or whether it occurred 3 weeks earlier, or anything like that. So you can have interval censored data, and censored data, as I say, is kind of a necessary evil, if you like, in a lot of survival analysis studies. SPSS statistics actually contains a number of different survival analysis procedures. The first one that we're going to look at in this series of videos is life tables. That's actually a descriptive procedure. It's probably the simplest way to look at survival analysis, a good way to introduce it. Then we're going to look at Kaplan-Meier, a slightly more sophisticated approach. And then we're going to look at Cox regression, which is really a predictive form of survival analysis, perhaps the most sophisticated, similar to logistic regression. There is in fact a fourth procedure. We won't be looking at it in this series of videos, but it's been recently introduced into SPSS. This is known as AFT models, or parametric accelerated failure time models. So it's quite a rich menu of different survival analysis procedures that one could work with within SPSS statistics. And the key output types that you should be looking for, if you're looking at typically within survival analysis, is what you get is something that shows it, typically something like a survival analysis table, which kind of gives you a description of at different time points people's survival chances. Then you usually have some sort of test or a group comparison table, which allows you to test whether or not one type of treatment makes a difference to another type of treatment. And thirdly, you tend to see things like these survival plots, which we'll talk about in more detail later on, but basically illustrate survival broken down by different groups over time.